Core 3 Review Sheet G Product and Quotient Rules. The questions on this video are not the same as those on the review sheet, but if you work your way through the video it will help you answer the review sheet. So first of all, we're looking to differentiate y equals 4x squared ln of 2x. The first thing to notice is that this is a product. You've got the y's 4x squared multiplied by ln of 2x. So what we need to do is apply the product rule. Now the easiest way to do this is to do a grid, put the 4x squared, which can also be called your u here, and then the second part, the ln 2x here, and then we need to differentiate each of them. Now a 4x squared, that's going to be very straightforward. All you do is 4x squared to 8x. But the ln 2x, be careful with this one. Actually apply your rules of logs first. Ln 2x, it's 2 times x, and when you're multiplying with logs, then that means that you need to add them. So ln of 2x is ln of x add ln of 2. Now when we differentiate, ln of x goes to 1 over x, and ln of 2 being a constant disappears. So when you differentiate ln 2x, you should get 1 over x. Now, the product rule says that dy over dx is u times dv over dx plus v times du over dx. That's a technical way of doing it. What you're actually doing, this is your u, you're multiplying it by the dv over dx. You're multiplying 4x squared by the 1 over x. Then here, this is your v times your du over dx. There's your v, there's your du over dx. So all you're doing is you're multiplying diagonally. So dy over dx becomes 4x squared multiplied by 1 over x, and then you add the ln 2x times 8x, and we'd normally put the 8x bit first, so you get 8x ln 2x. And we can simplify this. 4x squared times 1 over x is the same as 4x squared divided by x. Cancel one of the x's out, and that lot comes to 4x. So your answer is 4x plus 8x ln of 2x. The next one is a quotient rule. You'll notice instead of, whereas here we were multiplying two things, here it's a division, x squared plus ln x divided by 2x. Now in this case, the u is always the numerator and the v is the denominator. So u is x squared plus ln x, and your v is equal to your 2x. We differentiate each of them again. X squared goes to 2x, ln x 1 over x. 2x just goes to 2. Now we have to apply the quotient rule. Now this, although it's not set out exactly the same way, is in your formula book, so it's not one you need to remember. Dy over dx is v du dx minus u dv dx over v squared. Of course, if you can remember it, that's great. So dy over dx, v du dx, 2x times the 2x plus 1 over x. So it's 2x, and then the 2x plus 1 over x stays in brackets. Then take away u, x squared plus ln x, times dv over dx. Well, I'm going to put the 2 first. So it's 2 x squared plus ln x. I could have put x squared plus ln x and then the 2, but it's more natural to put the 2 in front. And it's all over v squared, so that's over 2x in brackets squared, all of the 2x squared. So basically it is work out du dx, work out the dv dx, and then you just slot everything in the correct place. So you're doing your v du dx minus your u dv dx over the v squared. And it's simplified. 2x times 2x, 4x squared. 2x times 1 over x, 2, because the x's there cancel. Here, minus 2x squared, and notice it's minus 2 times each bit, so the next one is minus 2 ln x. Now, usually you don't bother expanding the denominator, but in this case it's a very easy one. 2x times itself becomes 4x squared. And then simplifying, 4x squared minus 2x squared is 2x squared. You add on 2, take away the 2 ln x. All I've done is combine these two together. and then finally we see that 2 is a common factor. So you're left with x squared plus 1 minus ln x all over 2x squared. Let's now use it in a problem. You're told y is x squared plus x plus 1 e to the power of x, and you need to find the stationary points and whether each one is a local maximum or a local minimum. So we look at it and we say x squared plus x plus 1 multiplied by e to the x, product rule, straight to our grid. Differentiate x squared plus x plus 1, 2x plus 1, 2x plus 1, 0. E to the x stays the same. Apply the product rule. So it's going to be the u multiplied by the dv over dx and add the v multiplied by the du over dx. So the first one, the u, x squared plus x plus 1 multiplied by the dv over dx, e to the x. And then the other one is e to the x multiplied by 2x plus 1, but it's more natural to put the 2x plus 1 first, then the e to the x. Now we want to combine these. Now you could expand them, but the easiest thing to do is to say, well, I've got something times e to the x plus something else times e to the x. And so all you actually have to do is combine these two parts, and you're going to have x squared plus x plus 1 plus 2x plus 1 all times e to the x, which simplifies to x squared plus 3x plus 2 times e to the x. And for stationary points, that must be 0. So let's see if we can solve it. Well, the first thing, e to the x is never 0. Actually state that, e to the x is not equal to 0. So that means you're left with the x squared plus 3x plus 2 equaling 0. Solving this either by factorising on your calculator gives you x as minus 1 or x as minus 2. Now you are asked to find the stationary points. If they just ask for the x values, they're there. But if you want the stationary points, you have to find the y values as well. So we've got y is x squared plus x plus 1 e to the x, and we want to slot in x is minus 1, x is minus 2. So if x is minus 1 when you square it is plus 1, minus 1 plus 1. So that's just e to the power of 1, e to the minus 1, it's e to the minus 1. And if it's minus 2 when you square it is 4. Take away 2, add 1, that makes 3, e to the minus 2. So that means your two stationary points are when x is minus 1, then y is e to the minus 1. When x is minus 2, y is 3e to the minus 2. They're the stationary points. Now, are they local maximum or local minimum? Which is which? You know dy dx. We've got the dy dx here. X squared plus 3x plus 2 e to the power of x. So to find out if it's local maximum or local minimum, we'll differentiate again. Product rule again. X squared plus 3x plus 2, 2x plus 3. 2 obviously differentiates to 0. E to the x stays the same. Now, we're differentiating again, so we're going to get d2y over dx squared, and it's x squared plus 3x plus 2 lots of e to the x, add 2x plus 3 times e to the x. Well, we might as well combine this at this stage, because it's this times e to the x, add that times e to the x, will be x squared plus 5x plus 5 e to the x. Now, let's look at the two values for my x, minus 1 and minus 2. When x is minus 1, you get 1 minus 5 plus 5. So that's just 1 e to the x, e to the minus 1. And e to the minus 1 is positive, and so that means you've got a minimum. Then your next one, I should say, just because it's a negative index, it's still positive. E to the minus 1 means 1 divided by e. When x is minus 2, your d2y over dx squared, minus 2 when you square it is 4. Minus 2 times 5 is minus 10 plus 5. So it's 4 minus 10 plus 5. That's minus 1 e to the minus 2. Minus 1 times e to the minus 2 is minus e to the minus 2. Well, e to the minus 2 is 1 over e squared, so minus e to the minus 2 is minus 1 over e squared, which is negative. That makes that a maximum. So you've got a minimum at minus 1, e to the minus 1, a maximum at minus 2, 3e to the minus 2. Finally, find the equation of a tangent to y equals root x minus 1 times e to the x at a point where x is 4. Well, let's have a look at it. Firstly, let's change that root x into x to the half, and also realize that again it's a product, so you're going to use your product rule. So y is x to the half minus 1 e to the x, and we now use our product rule because it's a multiplying there. So let's be careful on it. E to the x is easy, that's going to go to e to the x. Here, multiply by the index, a half, and reduce the power by 1. X to the minus a half, notice the number on its own disappears. So dy over dx is u times the dv dx, multiplying diagonally x to the half minus 1, lots of e to the x, and then here v times du dx. So it's going to be e to the x times this. We normally will put the e to the x here, but we'll just be consistent, we're going to put it at the end. So you get a half x e to the minus a half e to the x. Let's combine it. Notice that the e to the x is a common factor. So you've got x to the half minus 1 plus a half x e to the minus a half all times e to the x. Now, when you want to do some more work with it, like slotting in x equals 4, and it may be easier actually to rearrange this, get it back in terms of root x's. If you're happy, you can actually key everything in on your calculator and you can leave it in this form. So you can actually deal with it in this form and immediately just start slotting in your x equals 4. Otherwise, let's just change it back into square roots. X to the half means root x minus 1 plus, and here it's 1 over 2, and this, if x to the half is root x, x to the minus a half is 1 over root x. So that's a half times 1 over root x, which is 1 over 2 root x. Obviously there's an ETX outside. So a half, 1 over 2, multiplied by 1 over root x. Now, slot in x is 4. If x is 4, root x is 2. So you're going to get dy over dx is 2 minus 1 plus 1 over 2 times 2 plus a quarter e to the 4. X is 4. So x is 4, root x is 2. That becomes 2. That stays as minus 1. That becomes a quarter, and that becomes e to the 4. Well, 2 minus 1 plus a quarter, that's 1. 1 and a quarter is 5 over 4. So that's 5 over 4 e to the 4. Now that is the gradient of the curve when x is 4. dy over dx being your gradient. We also, to find the equation of a tangent, you need to find the equation of the gradient, and you need the point as well, point it goes through. So you need to say, well, when x is 4, what is y? So y is root x minus 1 e to the x, root x is 2, so it's 2 minus 1, lots of e to the 4, which is just e to the 4. So that tells you that the point when x is 4, y is e to the 4, is 4 e to the 4. So the point on the curve where the tangent goes through is 4 e to the 4. The gradient of the curve is the same as the gradient of the tangent at that point. And at that point the gradient is 5 over 4 e to the 4. So now back to y minus y1 equals mx minus x1, which you'll have done in core 1. And you've got y minus the y coordinate, y minus e to the 4, equals the gradient, 5 over 4 e to the 4, x minus the x coordinate, x minus 4. Might look a little bit tricky, but basically it's just slot in the numbers that you've got. So y minus the y coordinate equals your gradient, x minus the x coordinate, and it doesn't actually ask you to put it in any form, so you don't need to expand this. If you wanted to, you could, but you don't need to. Okay, so good luck with your review sheet.